Hello everyone, and welcome to another episode of TD 202. In this episode, we will be looking at reproducing drawings in orthographic projection that consist of hidden portions. Stay tuned. Okay, so this is the drawing that we will be looking at today. Now, let's observe the drawing before we actually start. If you notice, unlike the other drawings that we have done so far, this time there are three faces facing the front. This face, the viewer can stand from the front view and see this face, additionally this face, and this face. Alright, so let me shade those. Okay. Now, from the side view, the end view, the person or the viewer is able to see this face. But if you notice, they should be able to see this face. However, it will be blocked by this portion of this face. So there are two faces facing that direction. However, from the side view, the viewer will only be able to see this one. But we have to take in account this one. For the plan view now, the viewer is able to see this face only. So let's count how many visible faces are there. 1, 2, 3, 4, 5, 6. There are other faces, but they are not seen here. All right, so let's start with the front view, which we normally do. If you notice, this face is some distance back, but from the front view, you will not notice that. All right, so let's start off with the overall measurement. And we're going to use first angle projection for this one. So I'm going to start by putting the face. Let me start at the lower left-hand corner. So I'm drawing my baseline, and I will measure 15 plus 15, 30 plus 20, 50. All right, so from each corner I'll measure 15 millimeters. And the height, as you can see, is 40 millimeters for this face. The measurement is shown here. It's also the same measurements here. Once I take the measurement for one side, I automatically am able to use it for the other sides. So I can go ahead and brighten. So if you look, the three faces that I've shaded are drawn. So we would not need to push back the middle face because we're looking from the front view. All faces will be in line unless one is taller than the other. Remember, this measurement, this direction, we cannot notice on the front view. We can only notice this and this. So anything going further back, we will not see. That's why this face and this face, these faces are in line. The height, if there was a height difference, you would have known. If there was a difference in width, as you can see, this is thicker, you can see that. So let's proceed to draw the plan view. And as you know, we'll leave a certain amount of distance when using 20 millimeters. So this is what I'm going to do. I'm going to project these lines upwards based on the amount of line, the points that are there. I only need 4 lines. 1, 2, 3, 4, 5, 6, 7, 8. These 4 down here, these points are in line with these points up here. So then I'll draw my line, baseline for the plan view. Let's have a look again. We have already established this measurement, so we now need this measurement, which is 30 millimeters. So once we start off with the plan view, we would have already gotten the measurement that is corresponding with the front view. The front view and the plan view share this measurement. So since this is 50, we don't have to measure 50 again. We just measure the other side, which is 30 millimeters. Now, if we look, we have the shape here. So this is the plan view. So we have the shape here. This is the lowest part of the plan view. So this is 10 millimeters, as you can see. And we don't need to measure the 20, as that measurement has already been transferred upwards. So I can go ahead and brighten. All right, we need the third view, and we need our 45-degree set square. So let's get it. We are going to draw the end view over the right. It's the right view that is shown right here. And since it's third angle projection, we're going to draw it to the right. So we're going to look for the uppermost point to the right on the front view, which is here. Then, as usual, we'll transfer all the points. These 4 points are on this line. These 2 points are on this line. And these 2 points up here are on this line. And let's bring across these 4 points at the bottom, these 4 points at the top. Then we let these points meet. Normally, for simple shapes, by the time you get this out of the way, you can see the shape being you can see the shape basically being carved out. Now, if you notice on the side view, we can see the 30 millimeters, which this is 30 millimeters and it has been transferred down. And you can also see the 40 millimeters. This is 40 millimeters and it has been transferred across. So basically, you have the shape already. All right. But if you notice, there's another face here. There's another line here that you won't see, but you have to represent it. If you realize there's a hole here, from the side view, you would not know that there's a hole here, except for this line that I've transferred. You would have to put a hidden detail line. So I'll use my short strokes to get them. So if you notice, looking at the shape, you will see this main shape. But there's also a line 10 millimeters back, 10 millimeters back, that shows that behind this shape, there's a cutout or a hole, as seen in the plan view. So you're basically looking at this side from the plan view, and the hole is back there. So you're seeing it there. Alright, so that's basically how you would represent hidden lines or hidden portions in an orthographic drawing. In future videos, you'll be seeing more complex drawings that would show more hidden lines. And as you go along, you'll get the hang of it. Please like, share, and subscribe, and have a good day. You should be able to put on the dimension lines and the dimensioning and the orthographic symbol on your own. Have a good day.